Okay, so hello everyone, and I'm very glad so many students have joined this session. I didn't expect this much of strength, so I'm very glad about it. So, I am Vishakha Pandey. I will be teaching you some concepts about mostly, I will be trying to solve the previous assignments and with the help of those previous assignments you can then try to solve your own assignment which will be given to you for different weeks. There will be different assignments, so uh, you will get a immense help through these kind of live sessions. So hi, uh, let's go to question number 6. Okay, now since we have already discussed so much, can you tell me the wrong characteristics of ideal op-amp from the options? Okay. Huh.
Ma'am, option D.
Option D, ma'am.
Why?
D.
Why?
There is good common mode rejection, ma'am, in of ideal of them.
D, ma'am.
What does common mode rejection means?
Differential gain to the common mode gain, ma'am.
It will reject the common mode signal.
You are not audible. क्या बोल रहे हो?
Common mode voltage is the average of the voltage between the inverting and non-inverting node.
Yes. Okay.
Average voltage, ma'am, is known as
Average
common
voltage.
mode.
Ma'am, common mode is where both terminals have the same input.
Both terminals have the same input. Mm,
Eliminates the common mode voltage from the output.
yeah. Okay. Yes. But I want
It's the ability of op-amp to reject the common mode signal.
common mode signal. Okay. What does that mean?
In noise
Common mode
signal,
difference.
in case of any noise, if you want to eliminate the noise means you can use this op-amp to reduce to cancel out the common mode signal.
Okay. So, okay, mute yourselves.
Common mode is differential voltage, ma'am.
Okay. Okay. So I will tell you what in a layman term what does common mode rejection mean. Okay. So see, let's go here. Okay. Yeah. So what common mode rejection means is, see, these are the two ports of the op amp, right? So if noise comes, right, so right, noise will come in both the input, both the ports, right, both the inputs ports will have some noise. So common mode rejection means that for this circuit it will identify what is common in both the terminals, which is common. Noise will be common, right? So it will identify, okay, this is the common, this is the noise which is common in both the ports, and it will reject it. This is what in layman's term means common mode rejection. Understood? So common mode rejection means that for both the ports there will be some noise which will be common to both the ports, and the circuit will identify, okay, this is the common, and it will be common noise, and it will be rejecting it. So since the operational amplifier is ideal here, it will have a good common mode rejection, right? Why? Because it is ideal. So the noises which will be common in both the ports, the ideal op amp will be rejecting both the noise from both the modes. So which is no. Let's go ahead.
Ma'am,
Yes.
ma'am, why output impedance is zero at in
Hmm.
why output impedance is zero at output, ma'am, in
Like output impedance is 0. Is that what you are asking?
Yes,
Okay. So mm, I ideally, so we want all the voltage, right? We want whatever is the output here, right? We want all that voltage out from the port, from the output of the circuit, right? So if there will be any resistance in the circuit at output, right, let's say there is a resistance, then what will happen is current will flow, and this current will produce a power, right? I square R, it will produce I square R, and heat will be dissipated, right? And there will be a voltage drop. Are you getting? There will be a voltage drop which will be equals to I into the R. One second, I will erase so much clutter over here. So here, right, let's say this resistance is R and the current is flowing is I, then there will be equals to IR, right? So the voltage here will reach V0 minus V. Let's say here, not V0, VO. So here let's say VO was the output of the circuit, but since there is a resistance attached in the output circuit, there will be a voltage drop which will be equals to IR, and thus the output at the port will be VO minus V, right? So we don't want that. For an ideal op amp, what we want is all the voltage here. So for all the voltage to be here, we want what will be the characteristic of the circuit? R will be equals to 0. Thus output impedance will be equals to 0, and thus we will get all the output here, voltage output here. Got it? Okay. Let's go ahead. Okay. So a summon inverting amplifier circuit is given in figure 1 with an ideal op amp. Okay. So this op amp is ideal here. Okay. Where V1 is equals to 2 volts, V2 is equals to 2 volts, V3 is equals to 4 volts, and V4 is equals to 10 volts. Okay. R1 is 1, R2 is equals to 2, R3 is equals to 4, and R4 is equals to 5. RF is equals to 20. Okay, so this is a closed loop amplifier, ideal amplifier, and this is the these are the values of the system. Okay, so I have you brought your copy and pen? I want you to solve it. I will give you uh, 4 minutes maybe. Okay, so take 4 minutes and try to solve it yourself first, and then we'll solve
Ma'am,
it.
minus 120 volt.
Okay.
Minus 120 volt.
Okay, very good. Very
Minus
good.
120 volt.
Don't give
Minus
answers
20.
right now. Wait, let others also solve. I want everyone to solve this. Guys, bring your copy and pen and try to solve this question. It's a very pretty simple question. It is you have sir has already given you the formula in the NPTEL lectures, right? So the formula is there with you. Try to solve it.
Option A.
Don't give answers right now.
The values of V2 and V3 are not visible. Can you please
Okay.
show them?
Now.
Yes, ma'am. Thank you.
हो गया मैम.
Okay.
It's done, ma'am.
Okay. Let others also solve. 1 minute और wait करते हैं, then we'll solve. Everybody solved? Okay, let's go. Yeah, so everybody solved? I'm writing the formula here. Okay. And now try to solve it if you haven't still. Guys, this is the formula for the summer inverting amplifier. Try to solve the question now. This is the formula.
Yes, ma'am. Option A, minus 120 volt.
Okay, very good. Others also solve. This is the formula for the summer. Try to solve. Look at your screen and now solve the question. I will write it here. Minus RF. Can anyone tell me why it is known as inverting amplifier circuit?
Input is connected to the
Because the input is connected to the negative terminal, so that's why.
Yes, very good. What else? What else? In layman's term, what can be said about it?
Output is negative
Yes.
and the input is positive.
Yes, very good, very good. So inverting है, so basically the polarity is changing. So input is all positive, but we are getting a negative output, which means it's inverting the polarity of the voltage, and thus it's a inverting amplifier. Another thing to understand, how can you identify that it's an inverting amplifier is by looking at the circuit here. All these resistances and voltage is applied. Input is given to negative terminal, right? So if it's given to negative terminal, then the output will be, what will output be? It will be opposite the polarity of the input, so thus it will be inverting the signal. So this is how you can identify the signal. So here put all the values, right? Put RF, R1, V1, all the values you will put, and you will get output voltage equals to minus 20 volts. I hope everybody have solved the question. Let's go ahead. Let's now
Yes,
try
ma'am.
to find out the current IF here. So what is the current of the circuit? Go ahead, try to solve the question. You have seen the circuit, but now we have to find out IF. So I'm giving you 4 minutes to solve this question. I think 4 minutes are good enough to solve. Please solve what IF is.
It is minus V output by RF.
Okay. Don't tell the answer right now. We'll discuss it in 3 minutes. After 3 minutes, we'll discuss. Okay.
Done, ma'am.
Okay, done. So yes, let's go. Yeah. So here current will be, how much current will be flowing through this is V0 minus 0, 0, since this is grounded, right? So V0 minus 0 upon RF. So how much RF will be?
20.
Minus 120, minus 120 divided by 20, right?
Yes.
This comes as minus 6.
-6.
One second. Yeah, so minus 6. Minus 6 milliamperes, right? Okay, the answers are completely something different. Anyways, so the answer here will be minus 6 milliamperes. Do you have any doubt, guys? Do you have any doubt here?
No, ma'am.
It will always be, ma'am, V naught minus 0.
Yeah, it's connected from this terminals, right? Yeah, for this circuit, it will be V0 minus 0.
As it is grounded.
Yeah, yes. So, options, wrong options are given here. Correct option is minus 6 milliamperes. You have any doubt? Anyone?
No, ma'am.
Okay, let's go ahead. Yeah, so now a summer non-inverting amplifier circuit is given. Here a non-inverting amplifier. Why it's a non-inverting amplifier?
Input is connected to positive terminal.
Yes, very good. Okay, so a summer non-inverting amplifier is given with an ideal op amp. All right, where V1 is equals to 3 volts, V2 is equals to 2 volts, V3 is equals to 4, R1 is equal R1, R2, R3 is equals to 8 ohms, RS is equals to 4 kilo ohms. Sorry, yeah, all of them are in kilo ohms. Okay, and RF is equals to how much? 40 kilo ohms. Now, what will be the output voltage? So try to solve this question. These are the options. Solve it and we will discuss. Don't tell answers, anyone, right now. So I'm giving you 4 minutes to solve this question and then we'll solve this together. Try to solve it right now by yourself. It's a easy question. All the formula and everything is given to you.
Ma'am, what is the value of R1?
One value is 8 kilo ohms. R1 is equals to R2 is equals to R3. It is equals to 8 kilo ohms. Okay.
Got it.
It's done, ma'am.
Done. Okay. Uh, I will give one more minute to solve. Guys, try, solve it fast. Okay, I will give you 30 more seconds. Guys, solve it if you haven't still. Okay. So let's solve. So for non-inverting amplifier, the summer becomes, the formula for summer becomes V0 1 plus RF upon RS. Here RS and RF, right? So 1 upon RS plus RS and into 1 RP upon R1 into V1, right? RP upon R1 into V1, RP upon R2 into V2, dot 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 RP upon Rn into Vn. So RP here is the resultant parallel resistor for all these resistors in parallel. So RP will be equals to 1 upon RP is equals to 1 upon R1 plus 1 upon R2 plus 1 upon dot 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 1 upon Rn. Okay. So here since R1, R2, R3 all are equal, so 1 upon RP becomes 3 by 8, right? Is there any doubt here till here? We have got RP is equals to 8 upon 3. Do you have any doubt here?
No, ma'am.
Okay, cool. So
Yes,
RP we
ma'am.
found, then
No, ma'am.
we'll put 1 plus RF. How much RF was there? What was the value of RF? 40 and RS is 4. Okay, so here 1 plus RF upon RS, so 40 upon 4, right? Into RP, that is 8 by 3 upon 1 by R1, which is 8 plus V1. V1 is how much? 3, right? Sorry, not plus. Plus again 8 by 3 into 1 by 1 by 3.
Ma'am, explain again.
Okay, so from where you want me to explain? Should I explain all the from starting?
From formula.
Okay,
Yes, ma'am. Yes, ma'am.
okay,
Formula is bit not clear.
okay, okay, okay. Okay, I will leave it there, here. Okay, I will see. So for a non-inverting amplifier, I hope you can see the circuit here. So for non,
Yes, yes.
can you see now?
Yes, ma'am.
Okay. So for a non-inverting amplifier, V0 is equals to 1 plus R of F, R of S. So sir has solved this exact circuit. Sir has solved in his NPTEL lecture, and from there you can find out how he has found out this formula. Okay, so this exact circuit is given, and he has given the formula for this circuit. This is a non-inverting amplifier circuit, summer circuit. This is a summer non-inverting amplifier circuit, and the formula is what?
Ma'am, OP amplifier means
OP amplifier, operational amplifier, OP amplifier
Okay, ma'am.
means operational amplifier. Okay, हाँ, R parallel R, RP upon R1 V1, okay, plus R RP upon R2 V2 plus dot for all the values RP upon Rn if n number of resistors are parallelly connected to the non-inverting port of the circuit. So this is the formula. Right? Is there any doubt you have?
No, ma'am. Thank
No, ma'am.
Okay.
No.
So now here RP is resultant resistance for all these resistors if these are connected in parallel. So RP will be equals to 1 upon, we will put the parallel formula, parallel resistance formula for all these resistance, and we'll get 1 upon RP is equals to 1 upon R1 plus 1 upon R2 plus dot 1 upon Rn. We'll put this, we'll get RP is equals to 8 by 3. Do you have any doubt till here?
No, ma'am.
No? Anyone? Any doubt?
मैम आंसर बता
you. No,
दीजिए
ma'am.
इसका.
No.
हाँ ठीक है, आंसर बता.
Excuse me, ma'am.
हाँ, go ahead.
Ma'am,
It's 33 volt.
ma'am, instead of using that formula, why don't we apply KCL at the inverting input and find the potential at the inverting input?
Do that, yes, we can do that, but it's a see what happens generally is uh, you can do that if you have a very a circuit which you have not seen earlier. But if you start applying KCL KVL to all the circuits, then you will take a lot of time to solve this kind of question. And generally what happens is in GATE or other competitive exams, they will directly give you this kind of circuit. They won't even give you the figure of the circuit, they will just give you that the sum and non-inverting amplifier circuit, and they will give you like that, and you have to solve. So so it's very good for you that you know the formula for these kind of circuits. These kind of circuits are typical circuit: non-inverting amplifier summer circuit, inverting summer amplifier circuit, inverting differential amplifier circuit, a non-inverting differential amplifier circuit. So these are typical structures, circuits, and it's always good to learn the formula. Gate वगैरह में you won't be getting lot of time. तुमको 2 मिनट या 1 मिनट का टाइम होगा एक इस टाइप का क्वेश्चन सॉल्व करने के लिए. 1 नंबर का क्वेश्चन होगा, तो तुम अगर केसीएल और केवीएल लगाने बैठोगे तो बहुत लंबा टाइम जाएगा. समझ रहे हो? ईएस के क्वेश्चंस जो होते हैं, ईएस वगैरह में तुम्हें 1 नंबर के क्वेश्चन के लिए तुम इतना लंबा टाइम नहीं ले सकते ना, 5 मिनट का केसीएल केवीएल लगाते बैठो तो.
No, ma'am, but KCL, it will make job easier here.
Okay.
Simply if we put KCL at inverting terminal, we will get the potential of inverting terminal, and by applying virtual short concept, the same potential will be applied to the non-inverting terminal, and then once we get the non-inverting terminal's potential, we can find out V naught. Simply 2 equation will make the job done.
Yeah, okay. Okay, so okay, tell me the voltage for this here. यहाँ पे voltage कितना होगा? इस यहाँ पे
3 volt, ma'am.
3 volts. Okay. So see, अगर formula याद है तो it won't take lot of time.
33 volt, ma'am.
Yeah, 33 volt at the end, right? So ये 33 वोल्ट्स आया, 3 इंटू यहाँ पे 1 प्लस 40/4 कर दिया, राइट।
Yes, ma'am.
बट ये इसलिए तुमको केसीएल इजी हो गया बिकॉज दीज वर इन proportion, राइट। ये सारे V1 V2 V3 R1 R2 R3 were in proportion to each other, so KVL KCL was easy, but it won't be easy for all the circuits where it's not proportional, exactly proportional. So then formula, if you have, then you put it in the formula and you'll get it. Or maybe अगर ज़्यादा parallel resistors होते then it would have been tougher. Anyways, everyone,
Yes, ma'am.
you got it right. 8/3 into 1/8 into how much? 4. So here we got 11.
11.
Here 8 cancel. 1 3 cancel.
2/3.
Right?
It will be 9/3 and
Yes.
3.
Yes. Right? 33 volts. Got it? Now let's solve. Okay. So a differential. So everyone got it, right? Do you have any doubt here?
No, ma'am.
No? Let's go ahead.